Welcome back. Today we're going to be talking about rational number operations, day number 2. So first things first, let's go over our content objective, which is students will be able to find the sum or difference of rational numbers. Language objective is students will be able to discuss whether your estimates make sense. And why am I learning this? Well, this is important for many real-world problems like finding the overall change in a bank account. So first, let's recall what a rational number is. It's basically any number that can be written as a fraction, which we're going to refer to as the form a over b. Also noting that b, which is the denominator, cannot equal 0. So these are some examples of some rational numbers: 6/10, -5, 2/3, 75%. All of these are rational. Why? Because I can write them as fractions. And remember from the previous lesson, we talked about when we're adding or subtracting, we need to make sure we have the same unit. So here, they're both apples. Here, notice the ones are lined up with the ones. In this case, the ones are aligned with the ones, the tenths with the tenths, etc. And in this case, making sure that we have common denominators. We always need to make sure we have the same units. Now, we're not combining things if they're different units. For example, apples and bananas, tens with the ones, etc. So at this point, what I would like you to do is go ahead and challenge yourself. You should be able to do this from the previous lesson. Go ahead and pause the video and try numbers 1 through 5 on your own. Okay, so now we're back. So let's go ahead and check our answers. So this is just kind of like a quick warm-up. Number 1, you should have gotten -13 1/10. Number 2, you should have gotten 5 3/10. For number 3, hopefully you noticed there is a subtraction, so you're going to have to add the opposite, which should have given you -4/10. Number 4, once again, there's subtraction, so we're going to have to add the opposite, which is going to give us 16 5/10. And then last but not least, once again, since it is subtraction, we're going to have to add the opposite, which should have given you -17 4/10. Okay, so now that we're all warmed up, let's go ahead and try some problems like this. It says in the instructions, find each sum. Explain why the sum is what you say. So notice here it says -12 4/10 minus 6 8/10 plus 15 5/10 plus -2. So the very first thing that I'm going to do is look for any subtraction, because if it is, I want to turn it into an addition problem. I do recognize the subtraction here, so we're going to add. The opposite of 6 8/10 is -6 8/10. Now that I've done that, what I'm going to do is essentially be applying the commutative property, which allows me to move the numbers around the operation. So I'm going to go ahead and add -12 4/10 with a adding -6 8/10 and adding the -2. So since all of these are negatives, I'm going to combine them all up and rewrite it. So here we have 12 4/10, 6 8/10, and 2. Where does the decimal belong at 2? Well, with the whole number, the decimal always belongs at the end, kind of the way a period belongs at the end of a sentence. So that's one good way to kind of remember that. So it's 2 with the decimals is going to be at the very end, like so. So I'm going to combine all of these together. Notice I lined up my decimals. That way I'm combining all the tenths together, all the ones together, and all the tens together. So here, 4 plus 8 is 12. Carry the 1. 1 plus 2 is 3, plus 6 is 9, plus 2 is 11. Carry the 1. 1 plus 1 is 2. So notice these were negative, so I'm going to go ahead and rewrite this as a -21 2/10. Plus, bringing this down, 15 5/10. So now that I've rewritten it, I can go ahead and compare. I definitely have more negatives. I have 21 2/10 negatives, and I have 15 5/10 positives. So how many more negatives are there than positives? Well, let's see. Oops. Let's find the difference between them. This is going to be 12. It's going to turn into a 0. 12 minus 5 is 7. We can't do 0 minus 5, so let's borrow. 10 minus 5 is 5. 1 minus nothing is 0. So my answer is going to be a -5 7/10. So to use my sentence frame, I'm going to say I concluded that the sum is -5 7/10. Why did I change the word to sum? Because I changed all of the subtraction into addition problems, so therefore it is the sum of all of the numbers here. So now let's try another one. Again, what I'm going to do first is check to see if I need to change any of my subtraction to addition problems. So that's already plus, here it's subtraction, so I'm going to add. The opposite of 10 and 900ths is a negative 10 and 900ths. So now I'm going to go ahead and combine all the negatives with all the positives. Let's start with positives. Here I have a 1 and 7900ths, and combine that with 2 and 8/10. I'm going to line up my decimals in order to do that. Notice by doing that, the ones are all aligned, the tenths are all aligned, and the hundredths are all aligned. So to figure out how many positives there are, I'm going to combine them. And that's going to leave me with 4 and 5900ths. Now I'm going to combine all the negatives. We have 3 and 2/10, and we also have 10 and 900ths. So I need to combine to see how many negatives I have. So I'm going to go ahead and do 3 and 2/10. I'm going to combine that with 10 and 900ths. Notice I'm lining up the decimals. Why? So that I can align the ones, the tens, the tenths, etc. So I'm going to combine these to see how many I have all together. I'm left with plus a negative 13 and 2900ths. It's very important that we don't drop the sign. That tends to be a very common mistake with a lot of students because they get busy doing some side work that they lose sight of the sign. So be careful. So first, let's decide. At this point, we can compare. Are there more negatives? Or are there more positives? Definitely more negatives. So at this stage, since I decided there's more negatives, I'm going to go ahead and compare how many more negatives there are than positives. So I have 13 and 2900ths negatives. We're going to compare that with the 4 and 5900ths positives. So here, to figure out how many more negatives there are than positives, we're going to find the difference. So here, we're going to have to borrow to make this a 12 and this into a 2. 12 minus 5 is 7. Here, we're going to borrow 12 minus 4 is 8. So my answer is going to be a negative 8 and 7/10. Why did I say 7/10 instead of 700ths? Because this 0 is not necessary. So I'm going to say I believe the sum is negative 8 and 7/10. So now at this point, what I'd like you to do is go ahead and pause the video and try number 8 by yourself. Okay, so let's see how we do. Hopefully, before you did anything, you turned all the subtraction into addition signs. So here, since this is subtraction, I'm going to have to add. The opposite of a negative 234 is a positive. Now that I've done that, I'm going to combine all my negatives with all the positives so that way I can compare. So here I'm going to go ahead and combine a negative 250 with a negative 198 I want to see how many negatives I have all together, so let's go ahead and combine those. Unfortunately, I'm unsure where the decimal belongs for 250. So let's remember, the same way a period belongs at the end of a sentence, guess what? With a whole number, the decimal belongs at the end as well. So there we go. Now I can go ahead and align them. And I can say altogether there are 350 and 9800ths negative. So I'm going to go ahead and write that down. So now that I've figured out how many negatives I have, I'm going to go ahead and do the same and figure out how many positives there are. So I'm going to go ahead and combine the 234 with the 221. So once again, this is a whole number, so one key thing to remember is where does that decimal belong for a whole number? It belongs at the end, kind of similar to how a period belongs at the end of a sentence. So here, let's go ahead and combine a 234 with 221. And I know this is right because notice the ones are all compared to the ones, the tens are all compared to the tens. Not compared, sorry, they're all aligned. And so here, if I combine them, I'm going to get a 4 here, 3 here, 1, 2, and 4. So here, I'm going to go ahead and add 421 and 3400ths. So now that I've separated them to negatives and positives, I can go ahead and start comparing. definitely more positives. Well, how many more positives are there than negatives? Let's find out. We're going to go ahead and put 421 and 3400ths positives, and there is 350 and 9800ths negatives. So here, in order to find out how many more positives than negatives, we need to find the difference. So we're going to have to borrow to make this a 14 and this a 2. 14 minus 8 is 6, and we're going to have to borrow again. 12 minus 9 is going to be 3. 0 minus 0 is 0. And we have to borrow once more here to make it a 12 and this a 3. So 12 minus 5 is 7. So here I would go ahead and also here 3 minus 3 is 0. So my final answer would be 70 and 3600ths. So to use a sentence frame, I would say I determined that the sum is 70 and 3600ths. Okay, so let's try another one. So once again, we want to make sure if we see any subtraction to turn them into addition problems. So here it's already plus, but over here it is subtraction, so I'm going to go ahead and add. The opposite of 35 is negative 35. And here, since it's subtraction, we're going to add. The opposite of a negative 19 and 3800ths is a positive 19 and 3800ths. So what we're going to do first, again, is go ahead and figure out how many positives we have altogether and how many negatives we have. So first I'm going to start with the negatives. We have a negative 21 and 7200ths, and we have a negative 35. There's a decimal here, which is nice. However, there isn't one here, so we need to remember the decimal belongs at the end, very similar to the way a period belongs at the end of a sentence. So I'm going to go ahead and combine all the negatives together. We have 21 and 7200ths with 35. And again, to me, this makes sense because all the ones are aligned and all the tens are aligned. So combined, I have a total of 56 and 7200ths negative. So I'm going to go ahead and write a negative 56 and 7200ths. Now I'm going to go ahead and combine all the positives together. So I'm going to combine a positive 18 and 9/10, a positive 33, and a positive 19 and 3800ths. So I noticed these two have a decimal, but this one does not. So I'm going to have to go ahead and figure out where that goes. The decimal does belong at the end, just the way a period belongs at the end of a sentence. So let's go ahead and figure out how many positives we have all together. We're going to add 18 and 9/10 with 33 and 19 and 3800ths. Could you add this step by step? Absolutely. I want to save myself some time, so I went ahead and I'm doing all three digits, all three numbers together. So here 0 plus 0 plus 8 is just 8. 9 plus 3 is 12, carry the 1. Here I'm going to say 1 plus 9 is 10, 10 plus 8 is 18, plus 3 is 21. Here 2 plus 1 is 3, plus 3 is 6, plus 1 is 7. So here I'm going to go ahead and put plus 71 and 2800ths. Now that I've separated them from negatives and positives, I can simply compare. There are definitely more positives. Let's see how many more positives there are than negatives. There are 71 and 2800ths positives, and there is 56 and 7200ths negatives. So how many more positives are there than negatives? Well, we're going to have to find the difference. So 8 minus 2 is 6. We're going to borrow. 12 minus 7 is 5. Here we're going to have to borrow again. 10 minus 6 is 4. 6 minus 5 is 1. So my answer is a positive 14 and 5600ths. So to answer the question, I'm going to go ahead and say I concluded that the sum is 14 and 5600ths. So now let's go ahead and move on to some numerical expressions. It says here, write a numerical expression, then find the sum. For number 10, it says Jen has $125.76 in her account. She deposits $45.90 and withdraws $80.02. Later, she returns to withdraw another $40.50 and deposits a check for $250. So first, before we do this, let's kind of do a quick recap. Whenever you're withdrawing money, we think about what's happening to your account. If we're withdrawing money, your account is, there's less money in your account. Now a deposit, if we're depositing money into the account, what's happening to our account value, to our accounts? We're getting more money. So deposits mean plus, withdrawals means negatives. So first we're going to start with $125.76. The first thing that she did was deposit. Because it's deposit, we're going to go ahead and add $45.90. Now, then she withdraws. Withdraws is subtraction because the account is losing money, so we're going to go ahead and put subtract $80.02. And then it says later she returns to withdraw another $40.50. So since it's a withdraw, it's going to be minus $40.50. And then here it says she deposits a check for $250. Since she is depositing, that's going to be a plus because you are getting money added to the account. So this is what our expression would look like. I'm going to go ahead and clean it up like so. So notice here it was expressed as add a negative. Why did I do that? Because it's very helpful. Or you could have realized here we could have done the same thing. It's subtraction. So what do I need to do? Add the opposite. Add the opposite. So either way, same idea. Now, would it save you some time if you put plus a negative? Absolutely. Is it okay if you decided to just put minus from the get-go? It's okay. Either way would work just fine. So, pretend we wrote it out like this. What should I do first? Just like before, I'm going to go ahead and combine all the positives together and all the negatives together so I can compare. So first, combining positives, we're going to combine these three numbers here. Oh wait, 250 doesn't have a decimal, so where does it belong? It belongs at the end, the same way a period belongs at the end of a sentence. So we're going to go ahead and combine all the positives together. We have 125 and 76 hundredths, 45 and 90 hundredths, and then we have 250. I'm going to put zeros as some placeholders. 6 plus zeros are 6, 7 plus 9 is 16, 5 plus 5 is 10, plus 1 is 11, making sure I bring down the decimal real quick before I forget. 4 plus 5 is 9, plus 1 is 10, plus 2 is 12. 1 plus 1 is 2, plus 2 is 4. So as of right now, she currently, not currently, but we've combined that there is 421 and 66 hundredths positives. Actually, I should say $421.66. I'm going to go ahead and combine all the negatives together. So here we're going to combine $80.02 with $40.50. So let's see how much we have all together. We have $80.02 and we combine that to $40.50. I'm going to have a total of $120.52. So I'm going to go ahead and add a negative, because those are negatives, $120.52. Now at this point I can go ahead and compare. There's definitely more positives, which is a good sign. That means Jenna is not in debt. So let's go ahead and figure out how many more positives there are than negatives. We have $421.66. Then we have $120.52. How many more positives were there than negatives? Let's find out. 6 minus 2 is 4. 6 minus 5 is 1. 1 minus 0 is 1. 2 minus 2 is 0. 4 minus 1 is 3. So that leaves me with a positive $301.14. So I would say Jenna currently has $301.14 in their account. Okay, so for number 11, why don't you pause the video and try this one by yourself. It says, write a numerical expression, find the sum. For number 11, it says, last week, Julio makes deposits of $84.09, $19.23, and $29 into his checking account. He then wrote checks for $53.87 and $38.99. What is the overall change in Julio's bank account? So first, what we're going to start with was, hey, he made a deposit of $84.09. So let's start with that. That's definitely positive because it's a deposit. And he also made a $19.23 deposit, so we're going to add that as positive. He also made a $29 deposit, so that's going to be positive. But then he wrote some checks. If you're writing checks, that means your accountant's going to lose money because you're paying someone with that check. So the first check was $53.87, so that's going to be plus a negative $53.87. And then again with another check of $38.99, so that's going to be plus a negative $38.99. At this stage, hopefully all you did was go ahead and combine all the positives together. Ooh, this one doesn't have a decimal. Hopefully remember it belongs at the end, kind of like the way a period belongs at the end of a sentence, like so. So here, let's go ahead and combine 84 and 900ths with 19 and 2300ths with 29. I know this works well because all the 1s are aligned and all the 10s are aligned. So here, putting 0 as a placeholder, 9 plus 3 is 12. 1 plus 2 is 3. Bring down the decimal. Here, this is 18. 18 plus 4 is 22. 2 plus 8 is 10, plus 1 is 11, plus 2 is 13. So there is $132.32. That's positive. Okay. And then we have some checks. So those are negative. So I'm going to go ahead and combine to see how many negatives there are. There is $53.87, and then there's $38.99. So I'm going to go ahead and add them. And I get, let's see, 8, 9. Bring down that decimal. So we're going to go ahead and put plus and negative $92.86. I'm not done yet. I need to, at this point, compare positives with negatives. Definitely would say that there's definitely more positives than there are negatives. How many more positives are than negatives? Well, let's find out. $132.32 positives with 92.86 negative. So notice I aligned my decimal. That way the 1s are aligned, the 10s are aligned, and everything else gets aligned in the process. And you see how many more positives there are. So let's go ahead and find the difference. 12 minus 6 is 6. We're going to have to borrow. 12 minus 8 is 4. We're going to have to borrow again. 11 minus 2 is 9. And here, base 12 minus 9 is 3. So how much is he left with? He's left with $39.46. So I'm going to go ahead and say Julio's current balance is $39.46, assuming he did start with 0. Okay, so now it says find each sum or difference. For number 12, we have 3 3/4 minus 2 5/10, or 2 1/2. So first things first, I see subtraction, so I definitely want to turn that into addition, so I'm going to add. The opposite of negative 2 5/10 is a positive 2 5/10. So our first option is to turn both into fractions, and our second option would be to turn both into decimals. So here let's practice turning both into fractions. This one's going to stay as 3 3/4, and I'm going to add that to 2 5/10, which could also just be read as 2 1/2. So this is one option. Now another option would be to turn them into decimals. So here, 3 3/4, hopefully you recognize that this could be read as 3 3/4. How much is 3/4? It's 75 cents. So I could rewrite this as 3 7/500, because it's $3.75 if you think about money. And I'm going to add 2 1/2, like so. Both would give you the same exact answer. So here let's go ahead and practice the fraction way. 4 times 3 is 12, plus 3 is 15, so we have 15 over 4. Plus, here, 2 times 2 is 4, plus 1 is 5. So now that we have improper fractions, let's go ahead and turn them into common denominators. I'm going to say 4 is definitely bigger than 2. And guess what? 2 can be multiplied to give me 4, so that's going to be my lowest common denominator. 4 is already a 4, so this 15 is not going to change. I'm going to go ahead and bring down the addition. 2 is not a 4 yet, but I could change it by simply multiplying it by 2. 2 times 2 is 4, which is exactly what I wanted. And 5 times 2 is what's going to give me a 10. So I am going to rewrite this like so. 4 is the denominator. I'm going to write 15 plus 10, which is 25 over 4. Now all I'm going to have to do is turn this into a mixed number, which should give me about 5. Let's see. Let's do it off to the side. 25 divided by 4. That goes in 6 times with a remainder of 1. So 6 1/4. So I'm going to go ahead and say this is 6 1/4. Now you could have done the decimal route as well. I'm going to go ahead and just add them together. 3 and 75 hundredths with 2 and 5 tenths to 5, 12, 1, 6, sorry, 1 plus 3 plus 2 is 6. So this is 6 and 25 hundredths. Guess what? These are equivalent because, again, you can read this as 6 and 1/4. What's 6 and 1/4? $6.25 when you refer to it as money. They're exactly the same. Now, is there a preference? Probably a lot of you will choose decimals for sure, but I do want to warn you with 8th grade, eventually when you start working a lot with both decimals and fractions, you're going to find we actually prefer turning things into fractions most of the time to keep our numbers exact and not having to deal with repeating decimals and such. Let's go ahead and try one more problem here. So once again, there are 2 methods. We can go ahead and write both as fractions, or we can write both as decimals. So here, I'm going to go first write both as fractions. So it's -2 and 1/4 plus 4, and you would read this as 3/10. So this is one method. Now another method would be to write both of these as decimals. So some of you, if you can remember from the previous one, we could read this as -2 and 1/4, which means it's just $2.25, which would look like this. But if you didn't know how to do that, what you would do is divide 1 by 4, numerator by denominator. Okay, decimal belongs at the end. 4 can go into 10 2 times. 2 left over, bring down to 0. 4 goes into 25 times evenly, and you would have gotten 0.25 just the same. So I'm going to go ahead and add 4 and 3/10. So I'm going to go ahead and show you both methods. So with fractions, and again, it's something that some of you may not pick, but it's going to be really good practice if you do. Here, what I'm going to do is turn it into an improper fraction. 4 times 2 is 8, plus 1 is 9, so this is a -9/4. We're going to add that to here. 10 times 4 is 40, plus 3 is 43/10. I like to pick the largest denominator first and ask myself, can 4 be made into 10? The answer is no. So the next multiple after 10 would be 20. Can 4 be made into 20? Yes, so 20 is going to be my lowest common multiple. Is a 4 already a 20? No. So I'm going to go ahead and multiply 4 by a 5 to make it 20. So I'm going to multiply this by 5 as well. I notice it's a tight squeeze, but I always tend to write things to the right of the existing number because that's generally what you do. So here, a -9 times 5 is going to be a -45. Now, you have to be very mindful of this negative. A lot of students will often drop it. Now here, is it 10 a 20? The answer is no, so I'm going to have to multiply by 2. So multiply 43 by 2, which is going to give you 86. Now I'm simply going to drop down this addition sign. Are there more negatives or are there more positives? Before I do that, let's go ahead and rewrite this. I'm going to go ahead and say that the denominator can still be a 20. I'm going to rewrite this as -45 plus 86. Is there more negatives or are there more positives? Definitely more positives. How many more positives are there than negatives? I'm going to have to subtract to find that out. So I'm going to be left with 41/20, which if you turn that into a mixed number, notice there's a lot of side work here. I'm not going to say fractions are the quickest way to go, but it's well worth it, especially when you go to 8th grade. 41 divided by 20, that goes in 2 times, with 1 left over, so 2 and 1/20 is my final answer. But then there's always the option of doing decimals, which, like I said, a lot of you will probably choose. There's definitely more positives. How many more positives are there than negatives? Let's compare. 4.3 with 2.25. Here, we're going to have to borrow, make this a 10, a 2. 10 minus 5 is 5. 2 minus 2 is 0. And then here, that's going to be a 2. So here, you're probably thinking, wait, Miss Singh, that doesn't really look the same. But I can prove it to you. I'm going to say that these mean the same number. How? Well, I can read this as 2 and 5 hundredths. And guess what? 5 hundredths can be reduced by 5, which would leave me with 2, and 5 divided by 5 is 1. 20 divided by 5 is 20. Oh, look, that's exactly the same as this. So now at this stage, what I'd like you to do is go ahead and try number 14 by yourself. Okay, so let's see how well we did. There was two methods. Method 1, turn everything into fractions. You should have gotten 1 3/8 plus negative 3 1/4. Or if you decided to turn everything into decimals, you should have gotten 1 375 10,000ths plus a negative 3 2500ths. If you did the fractions, you should have gotten negative 1 7/8. If you got a decimal, you should have gotten negative 1 875 hundredths. Do they represent the same exact number? They do. So either one would have been fine. So guess what? That actually concludes the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.